Bismillahirrahmanirrahim. My name is Hamzam Zafar, and the topic of my presentation is vision requirements and technology trend of 6G. So, starting with the 6G, as we know that 6G is the sixth generation standard for wireless communication technologies that support cellular data networks. And the outline of the presentation is, first we will discuss some versions of 5G, and after that the vision and requirements of 6G technology, the technologies that are used in 6G, the challenges that are being offered to those technologies, and the conclusion at the last. So starting with the review of 5G development, the working on 5G was started in 2013, and in 2016 its standardization was formally launched in 3GPP, and after that in 2017 the first version non-standalone was finished, and in 2018 the second version standalone was finalized. So we have discussed already these standards in our class also. So the commercialization of the 5G was started in 2019, and it is still under development widely in the world. So the key performance indexes by ITU, International Telecommunication Union, for the 5G. These were the data rate of enhanced mobile broadband of almost GBs per second, and the millisecond air interface delay for ultra reliable low latency communication, that was that is around 10 milliseconds of interference delay, and 1 million connections per square kilometer to support massive machine type communication. So if we look at the 6G with overall overview of 6G, so we can see that in 6G we'll use terahertz and visible light for indoor and short distance like communications, and then the cellular mobile communication and base stations for communication, and also it introduces the satellite communication integration with computer networks, so for global coverage for areas like deserts, oceans and forests. So the vision and requirements of 5G, the 6G is 6G should be ubiquitous and integrated network, so that it can support broader and deeper coverage and can serve in various environments such as airspace, land and sea. Second 6G is expected to work on a higher frequencies to achieve wider bandwidth and terabyte per second of peak data rate, and 10 GBs per second of user experience data rate. 6G also involves the artificial intelligence, so it's a personalized intelligent network, and endogenous security schemes is by introducing trust and safety mechanisms. 6G will have the capability of self-awareness, real-time dynamic analysis, confidence evaluation, and finally generate massive data through Internet of every things by combining novel technologies such as blockchain, artificial intelligence and edge computing and cloud computing, etc. So looking at the possible capabilities comparison of some major factors of 6G with 5G, we can see here in the table at the top that 6G will offer almost more than 100 GBs per second of peak data rate as compared to the 10 GBs per second data rate of 5G, and after that it gives the Many other such factors like as delay of less than 1 millisecond is compared to the 10 milliseconds of delay in 5G technology, and some other factors like coverage percent of more than 99% is compared to the 70% of 5G. So the key technologies that and new methods that are being used in 6G technology are here listed, like the visible light band and terahertz band, and new resource modulation, that is orbital angular momentum (OM), and new core networks, also the satellite mobile communication and artificial intelligence. So we will discuss these technologies one by one in the coming slides. So the first one is the expanding coverage, the integration of terrestrial and mobile communication. So 6G will integrate the terrestrial and mobile communication by involving satellite communication with the mobile computer communication networks. So it combines these two technologies that were established with separate standards in ITU. And for this, the satellite communication, the 6G will mostly use the lower Earth orbit satellites that are around about 500 to 2000 kilometers above the Earth's surface. So these satellites will be used. So the major challenges that are coming in the satellite communication is the Doppler shift and Doppler variation. Is the movement speed of Earth is different with the satellite speed, so it may cause Doppler shift and Doppler variation and large transmission delays due to around 1000 to 2000 kilometers of distance between Earth's surface and satellite. So it will give rise to large transmission also. The next technology is the second new resource and utilization method of spectrum, that is terahertz and visible light band. The 6G will support terahertz band from 0.1 to 10 terahertz and visible light band from 400 terahertz to 800 terahertz. These two are recognized as ultra-wide spectral bands to enable ultra-high data rates, and the visible light will be mostly used for indoor communication networks. And high-frequency hardware components is also offering in 6G, as it is difficult to design a radio frequency circuits such as terahertz mixers. So high frequency modulator design is also a technology of 6G. The terahertz communication channel modeling and estimation is the terahertz channel modeling needs to consider several unique factors, including the high frequency selectivity path loss due to absorption of oxygen and water vapor molecules, and mutual coupling and near field effect. So the challenges in visible light communication is first of all the bandwidth enhancement. Is the commercial LEDs typically have a very limited modulation bandwidth and slow modulation responses, so which directly limits the achievable data rate for visible light communication. And then the non-linearity compensation is the current flowing through the LEDs and the light emitted by the LEDs have non-linear relationship. So this non-linearity will also be a challenge for visible light communication. The MIMO techniques, multiple input, multiple output MIMO techniques, are also supposed to enhance the VLC rates, but MIMO systems are difficult to realize in a visible light communication due to like their diversity gains and or their design of MIMO receivers is also difficult. The intelligent dynamic spectrum access is the 6G will require the complete information about the network state and for optimal dynamic spectrum access policies. However, the existing protocols can't effectively adapt to more complex real-world scenarios. The next technology is the OM, that is orbital angular momentum, that is a kind of wavefront with helical phase and can be used as a new resource for modulation in wireless communications. Orbital angular momentum is defined in an infinite dimensional vector space, and it basically operates on the different data streams can be modulated on different time modes, but mostly the modes 0, 1 and 2 are used. So the challenges for this technology is its first of all beam divergence, as the OM beams are divergent, which limits the efficient reception of long distance propagation in OM based wireless communications. And the transmission is also a challenge, as the OM can be used for line of sight environments very well, but for non-line of sight environments it doesn't perform so effectively. And transceiver misalignment is also a challenge, because the transmitter and receiver are misaligned with each other in practical wireless communication scenarios. However, the transceiver misalignment makes it challenging for distinguishing multiple OM modes at the receiver. So here we can see the radiation pattern of OM modes and the 3 radiation patterns. Mostly these are used as we can see here that at the center of these shapes there is the angle theta that increases with the increase in the number of modes from 0 to 2, and if we increase more number of modes, so that the divergence will be more. So increasing the system capacity, the DCellular and UDN network architecture increases system capacity by involving AP group to serve each user. This is technology like that different base stations that are served to a single user by performing its APs groups. So this will also increase the system capacity, but on the other hand it also has some limitations and challenges. That first one is mobility management, is the users while a user is moving, its APs group will be dynamically adjusted or refreshed to support its movement, so it needs to be refreshed with that movement speed. And interference management is there are large number of base station involved, so there will be much interference. So for that the artificial intelligence needs to be introduced to solve such complex problems. And the fifth technology is the artificial intelligence technology that is 6G offered, and as we know that AI is a trump card to extend the coverage, meet diverse requirements of massive application and improve performance significantly. So the current wireless network should be changed and revolutionized from the traditional function centralized type into a novel 3C type, that is user centralized, function centralized and data centralized. So the challenges is with the heterogeneity, is the 6G is highly heterogeneous, so such heterogeneity makes it difficult and expensive to intelligently coordinate the communication. Hardware constraints on edge AI is the 6G devices are with limited communication resources, computing power and storage, so existing AI algorithms may result in degradation of performance. The new core network that will be established is that will support the integrated communication, including in air, space, earth, and everywhere communication. The challenges for this new core network will be intelligent mobility management, as the existing networks didn't take moving nodes like the satellites that are moving into account. So the mobility management will be a challenge, and protocol as the TCP IP or present protocols are for computer networks, not for satellite networks. So that protocol should also be developed for these networks. Now the roadmap suggestions for 6G standardization, as the vision and trend of 6Gs are being processed, and the standardization or technologies evaluation will be done some years later, around 2030. So this picture shows the roadmap for the 6Gs implementation. So concluding this, that research on 6G is being under discussion, and 6G will support development of intelligent mobile society with intelligent life and industries. It will give 10 to 100 times high overall capabilities, and its pre-commercial network will be available around the year 2030. So that's all, concluding with thank you.